there is a degree of overlap this section here with the work on chemistry. We're going to look at atomic mass and atomic number. What atomic mass refers to is how much matter a nucleus has. And an easy way of understanding it, but it's actually technically wrong, is imagine how heavy is the nucleus. And basically the way you work out how heavy the nucleus is by counting up the protons and the neutrons, add them together, and that's your atomic mass. But make sure you know that it's how much matter the nucleus has. The atomic number is the number of protons it's got, and it'll become a bit clearer as we go through a couple of examples of what we mean by that. Here is the atom of a hydrogen atom, and it shows you a proton, and for every proton there's an electron. So just to make sure that the atom is neutral, you've got one plus and one minus, and the minus orbits the proton. If you look at the way it's written, which I'll call the notation, you've got the symbol H for hydrogen. The purple one refers to the number of protons, so there's one proton. The orange one refers to how heavy the nucleus is. It's really how heavy the atom is. Now, since electrons weigh so little, 1/2000th of a proton, we ignore their mass. So in the center there, you've got one proton, so it's got a mass of 1. If we now added another proton, okay, so you've got 2 protons. Well, first of all, those 2 protons don't want to be next to each other. They repel each other because they're both positive. So we need to have something to glue them together, and that's what those 2 ends are, those 2 neutrons are. They glue the nucleus together. So if we count the number of protons, you've got 2 protons, and that's shown by the red 2 next to helium, the symbol for helium, He. And if you count the number of things in the nucleus, you've got 2 positives and 2 neutrons, which is 4 altogether. So you've got, there's the notation is 4,2. Now if we add another proton, it makes a totally different substance. In this case it's lithium, and it turns out that we need 4 neutrons to bind these protons together. And again, you can see that red, you've got 3 red bits, and that's shown as 3 in the lithium symbol, and then the total number of particles in the nucleus is 7, and that's the atomic mass, that's 7. You should be getting the hang of this now. You should be able to work out what this one's going to be. And here we go. How many protons does it have? There you go, 4 protons and 5 neutrons. There's a quick way of working out the number of neutrons. If you've got a notation like this, this is I think this is a beryllium, I believe, Be. You see it's got number 9 on the top and 4 below, 9 being the atomic mass for the proton number. Of course, the number of protons you've got is equal to the number of electrons. So that 4 tells you there's 4 protons and 4 electrons. And to work out the neutrons, you just take the 4 away from the 9, it gives you 5. So for every time you see a number like that, you can quickly work out the number of protons, neutrons and electrons. I've got some examples here with the answers written down, but you should really probably just write the stuff down in black, then try to work out the number of protons, electrons and neutrons for each of those. It's just good practice. Isotopes. Isotopes basically have the same number of protons, okay, they have the same atomic number, in other words the bottom number will be the same, but they have different numbers of neutrons, and they have a different mass number. Now we'll be seeing these a lot more when we start talking about nuclear processes. If they have different numbers of neutrons, they tend to be unstable. They want to break up, and then they're known as being radioactive. Famous isotopes include hydrogen and carbon-14. I'm going to show you some hydrogen ones now, for example. So here we've got 3 hydrogen atoms. They all would, for example, do the pop test, but they have slightly different properties. In fact, obviously the one with 3 things in the nucleus, which is on the far right there with notation 3,1 hydrogen, it's got 1 proton and 2 neutrons. That is much heavier than the hydrogen on the left. It's known as heavy hydrogen. So it's 3 times as heavy. You can see that quite clearly. But if you notice, each of those individual nucleuses, or nuclei I should say, have got 1 proton. They are all hydrogen. It's just the number of neutrons that has changed. And those are the isotopes of hydrogen. And of course, we use the isotopes of hydrogen using things like hydrogen bombs. And that essentially is it. What you need to know about atomic mass and atomic number.